Good morning students. Today we are going to discuss a very important topic from chapter 4, and the chapter 4 is your motion in a plane. The topic which we are going to discuss is your relative velocity in plane. So already we have discussed relative velocity in scalar form, so that definition we are going to use it here. Now in the diagram we have considered two objects A and B. Both are moving with different velocities. One is your VA vector, another one is your VB vector, making an angle alpha. Now we are interested in defining relative velocity of B with respect to A. So as per the definition in our previous class, so it should be your VBA, and the VBA is nothing but is your VB minus VA. So as it is in plane or it is in vector form, that's why we have to give the vector notation. So VBA vector equal to VB vector minus VA vector. So this one you can write like this, VB vector plus of minus VA vector. So you have to add two vector, one is your VB vector, another one is your minus VA vector. So in the diagram we know VA vector and VB vector, so we have to construct minus VA vector, and for that we have to extend VA vector in opposite direction. Now you do have two adjacent sides of the parallelogram, one is your VB vector, another one is your minus VA vector. So if you have to define the vector sum, what you have to do, you have to consider the diagonal which passes through the intersecting point of the two vector as per the parallelogram law of vector addition. So VBA vector is the diagonal, and we have constructed a parallelogram whose adjacent side is your VBA vector and minus VA vector. So if alpha be the angle between VA vector and VB vector, so angle between VB vector and minus VA vector is your pi minus alpha. So we have to use the parallelogram law of vector addition. So what we have to do, we are going to use directly the expression, because we are not supposed to derive the expression here. So VBA, the magnitude form is nothing but is your magnitude of minus VA vector is nothing but is your VA, and magnitude of VB vector is nothing but is your VB. So VA square plus VB square plus 2VA VB cos of the angle between the two vector, one cos of pi minus alpha. So if you find cos of pi minus alpha by using ASTC rule, you will get minus cos alpha. So ultimate expression is your VBA is equal to root over VA square plus VB square minus 2VA VB cos of alpha. So VBA is the magnitude of the resultant vector. Now if you have to define direction, and if beta be the angle made by VBA vector with minus VA vector, then tan beta is your VB cos of VB sine of pi minus alpha divided by VA plus VB cos of pi minus alpha. So sine of pi minus alpha is your sine alpha itself, and cos of pi minus alpha is your minus cos alpha. So ultimately tan beta equal to VB sine alpha by VA minus VB cos alpha. You can find beta equal to tan inverse of VB sine alpha by VA minus VB cos alpha. So you can define a direction also if you know the angle beta, because beta is the angle made by the resultant vector with the minus VA vector. Now we are going to use some specific value to define the magnitude and direction. So if we consider alpha equal to 0 degree, then you can substitute for VBA the magnitude part resultant, VA square plus VB square minus 2VA VB. So ultimately we will get VB minus VA whole square is nothing but is your VB minus VA. So if you have to define the relative velocity, and if the two objects are moving in same direction, then you have to take the difference of the velocity to get the relative velocity. Now substitute means simultaneously, if you substitute alpha equal to 0 in equation 3, you will get tan beta equal to 0. So ultimately beta equal to 0. Now you can define another value, alpha equal to pi. So if you substitute alpha equal to pi, then the expression you have to use cos of pi. Cos of pi is your minus 1. So ultimately we will get VA square plus VB square plus 2VA VB. So VA plus VB whole square. So VA plus VB. So if two vectors are in same direction, then you will get difference between the two magnitude, and if the two vectors are in opposite direction, then you will get the resultant by simple addition of the magnitude. And simultaneously, if you substitute alpha equal to pi, then sine pi goes to 0. So you will get tan beta equal to 0. Now similarly, you can define relative velocity of A with respect to E by using the expression BAV vector equal to VA vector minus VB vector, and correspondingly you have to change the diagram. here you have to define minus VB, so you have to extend VB in opposite direction. Now similar expression you will get by considering corresponding angle pi minus alpha. So it's here again VA square plus VB square minus 2VA VB cos alpha, and similarly the direction is also you will get VB sin alpha by VA plus cos of pi minus alpha is your minus cos alpha. So be careful during the calculation part. So here what you have to do, cos of pi minus alpha is your minus cos alpha, so it should be your minus. Okay, cos of pi minus alpha is your minus cos alpha, so be careful during the calculation part. There may be some mistakes because so many expressions you have to write. So this is one important topic. Now we are going to apply this one in case of relative velocity of rain with respect to a moving man. Suppose a person is moving with the velocity vm vector, m for man, and rain is falling vertically downwards. Now what we have to do, you have to define relative velocity of rain with respect to man. So what you have to do, you have to define minus vm vector. So you have to construct a vector which is in opposite direction of vm vector. So the resultant is nothing but the diagonal of the two intersecting vector at the intersecting point, the diagonal which passes. So vrm vector. Now if your this one as the angle between moving person and the rain is 90 degree, that's why you are going to use the parallelogram law of vector addition, that is your vr square plus vm square plus vrvm cos of pi by 2. So ultimately we will get vrm equal to root over vr square plus vm square. And if theta be the angle made by the resultant with vr vector, then you will get vm sin of pi by 2 by vr plus vm cos of pi by 2. So sin of pi by 2 is your 1, cos of pi by 2 is your 0. So ultimately we will get tan theta equal to vm by vr. So theta equal to tan inverse of vm by vr. So theta is nothing but the direction. So direction of the relative velocity of rain with respect to man. So if you have to protect yourself from rain, what you have to do, you have to hold the umbrella at an angle theta with respect to the rain. Then you can protect yourself. And for that you have to define velocity of man and velocity of rain. So depending on the vm and vr, theta changes, and correspondingly you have to make your umbrella as per the inclination required with respect to the value of velocity of rain and velocity of man. So this is all about, but there are so many expressions, so that's why be careful about the calculation. There may be a little bit mistakes, so if you practice, then it becomes very clear for you. Try to check it out and put your doubt. In next class we are going to practice few numerical from NCERT exercise, and after that we switch over to the next chapter. Thank you.